Hi friends, welcome to my channel Olympiad Math. In today's video, we are dealing with an interesting problem from algebra. To be more precise, laws of exponents, which is an integral part of all highly competitive exams like Olympiad, SAT, GRE, GMAT, and so on. We are actually simplifying an algebraic expression like k to the power of x cubed, the whole raised to 1 over xyz, multiplied by k to the power of y cubed, the whole raised to 1 over xyz, multiplied by again k to the power of z cubed, the whole raised to 1 divided by xyz. Here I will give you the shortest possible solution, making use of some basic laws of indices. So keep watching until the end of the video. To begin with, let me take the first term of the algebraic expression for simplification. There are three terms. The first one is k to the power of x cubed, the whole raised to 1 over xyz. This equals k to the power of x cubed multiplied by 1 over xyz. This is based on this rule of index. A to the power m, the whole raised to n equals a to the power of mn. Here m is equal to x cubed and n equals 1 over xyz. Now this I can write as k to the power of x cubed divided by xyz. Now these are like terms. We can further simplify this part. So that's equal to, we will make use of this law of index, x to the power m divided by x to the power n equals x to the power of m minus n. Here you have x to the power of 3 divided by x. That equals, x means x to the power of 1, which implies x to the power of 3 minus 1, and that's equal to x squared. So I'll substitute that here. And you have k to the power of x squared divided by yz. So we got this thing simplified to this expression. Now if you compare this to the second term, the only difference you can see, instead of x cubed, you have y cubed. So following the same method, k to the power of y cubed, the whole raised to 1 over xyz equals k to the power of y squared by xz. See, instead of x, you have y cubed. Similarly, the third term, which is k to the power of z cubed, the whole raised to 1 by xyz will be k to the power of z square divided by xy. Now let me substitute these simplified forms in the given algebraic expression. So let me rewrite the given expression using the simplified forms. This instead of these three terms. And you will have k to the power of, the first term is x squared by yz. Second term is y squared by xz. Third term is k to the power of z square by xy. This equals k to the power of x squared by yz plus y squared by xz plus z squared by yz. Actually, we have made use of one law of index, which is like a to the power m multiplied by a to the power n equals a to the power m plus n. Here in the basic law, we have two terms. Here you have three terms. So you get this. Now in the next step, let me simplify the exponent. See, we got the whole thing converted into k to the power of an expression containing three terms. This let me simplify separately and then substitute here. Okay, I'll do it on the margin. X squared by yz plus y squared divided by xz plus z squared by xy. Sorry, there was a minor discrepancy. This term is z squared by xy. Instead I wrote yz. So I corrected here, and that correction has been factored in here. Now this equals, let me multiply the first term, both the numerator and denominator, by x. So you get this. Similarly, the second term by y. So you get y x is z. And the last term by z. Z square, z multiplied by z square, z xy. This equals, see, this is actually x to the power of 1. And using this rule, you will have x to the power of 1 plus 2, which is like x cubed, denominator y is y cubed. We have multiplied the first term by x. So there was 1x down in the denominator, which I forgot to mention. So you will have actually this term, when you multiply both the numerator and denominator by x, 1x comes here and then another x comes here. This combined with this. Similarly, here you have y cubed, denominator will be xyz. It is actually yxz. Let me write it as xyz. And this will be z cubed xyz. And that equals, see, we have the same denominator. So you can write it like this, xyz, x cubed plus y cubed, z cubed. So the power of k, which is this expression, we have simplified into this form. And let me substitute this for this. So you get k to the power of x cubed plus y cubed, z cubed divided by xyz. Now there is an important result in algebra which says, given three variables x, y, z, if the sum of three variables equal to 0, then sum of the cubes of these variables will be 3 times the product of these variables. See, this simply means if you have three real numbers whose sum is 0, which is the case when one or two of them are negative, the sum of the cubes of those numbers will be thrice the product of those numbers. There is an important result in algebra, and we are going to apply that in this problem. If you refer back to the question, it says x plus y plus z equal to 0. It's given in the problem. So the numerator expression, this one, x cubed plus y cubed plus z cubed will be 3xyz. Denominator x, y, z. Using this result, and this xyz will cancel out with this denominator xyz, and you will have k to the power of 3. So this is the final answer to the simplification of the given algebraic expression. If you liked what you saw in my video, please like and subscribe to my channel. There are many such videos coming up, giving smart solutions to tricky problems, covering all areas of mathematics. So hit the like button so as not to miss out any such videos. Thanks for watching and see you in the next video.